Hi, for writing condensed electron configuration, we have to get help from the noble gases. But before you start watching this video, I recommend you to see the video that I talk about how to name electron configuration to learn this video so better. But a question might arise for you that why we use condensed electron configuration? The answer is so easy. Because it is short. Yeah, for example, if you remember the condensed electron configuration, it takes a long time from us to write it. And it has a huge electron configuration. But if you wanna write it in condensed mode, it will change to this. As you see, it is too short. Now we wanna write any elements in condensed electron configuration mode. Watch this video. Let's do that. As I said, when we want to write the condensed electron configuration, you have to get help from noble gases. The noble gases are the last group in the periodic table. They start with helium and ends up with guanosine. Yes, the famous guanosine. All of these elements ends up with P6, except helium. Its atomic number is 2 and it ends up with 1 is 2. The last video I told a rule for you that in any shell it starts writing with S orbital and ends up with P. As the noble gases are the last elements in their period, so they finish with P, except helium that has only 2 electrons, so it can get P orbital, so it will end up with 1 is 2. Then we have neon as it has 10 electrons as its atomic number is 10, and with the neutral mode the number of electron and proton are 12, so it will end up with 2p6. The next one is argon, its atomic number is 18 and it will ends up with 3p6. The next one is krypton, its atomic number is 36 and it ends up with 4p6. The next one is xenon, its atomic number is 54 and it will finish with 5p6. The next one is radon. Its atomic number is 86 and it ends up with 6p6. The last one is argonism and its atomic number is 118 and as you remember it ends up with 7p6. As I said, we get help from some methods to write condensed electron configuration. The first one is the rule that I talked about, is that any shell starts with S and ends up with P. But we need one more method. For writing condensed electron configuration, we should get help from the last previous noble gas. For example, if you wanna write the condensed electron configuration of the elements that its atomic number is 12, we know that it is between neon, that its atomic number is 10, and argon, that the atomic number of argon is 18. But which one of them are usable for us? As I said in the note number 2, we have to use the last previous noble gas. So I have to use neon. Now it's time to do some example to find out these notes so better. The first example that I wanna write it in condensed mode is beryllium. The atomic number of Be is 4, so it is after helium. As note number 2, I have to use the last previous noble gases, and it is helium. I write it as its atomic number is 2, and we need 4 electrons because the beryllium atomic number is 4, so we need only 2 more electrons. So helium is the last element in shell number 1, so you have to write 2s, as we need only 2 more electrons. We put 2 above the s. It's done. The next example is phosphorus that is shaded with P. Its atomic number is 15, and we know the neutron mode, the number of proton and electron is 12. By helping from note number 2, we have to use the last previous noble gas, and it is neon because its atomic number is 10. The argon atomic number is 18, so we use neon. And we know the neon is the last element in the shell number 2. So we have to start with 3s2. As note number 1, we have to start any shell with s. Till here, we have 2l electron. As neon has 10, and we add 2 more by 3s2. So we need only 3 more electrons. And we know after 3s2, we have to write 3p3. Because we needed only 3 more electrons. It's done. The next example I choose it from Dirac elements, and it is zinc. We show it with Zn. Its atomic number is 30, so it is between argon, its atomic number is 18, and krypton, its atomic number is 36. As node number 2, we have to use the last previous noble gas. So we have to get help from the argon. So we write argon. Till here we have 18 electron. As it is the last element in the shell number 3, we have to write 4s2. Till here we have 20 electron. So we need 10 more electron. And after 4s2, we know that we have to write 3d10 because we need 10 more electron. It's done. The last element I choose from F-block levels that we wrote it in the last video that we talked about total electron configuration. And it was plutonium. Let's write it in condensed. Plutonium has 94 protons, so in the neutral mode it has 94 electrons. That's a huge electron configuration. But in condensed mode, if we use radon, because it is the last previous noble gas before plutonium, as radon has 86 electrons, so we need only 8 more electrons. Radon is the last element in shell number 6, so we have to start with 7s2, and we know we have to write after 7s2 5f. Now still here we have 86 plus 2, 88 electron, as radon has 86 electrons and 7s2 has 2 electrons. We have 88, so we need only 6 more electrons. So we put a 6 on the top of 5f. It's done. Wait a minute. One question. What is the only element in the periodic table that we can't write it in a condensed electron configuration? Comment it for me. Good luck.